Hi, 215. Okay, so I'm going to try to solve your problem of the week for you on a screen share from Zoom, and we'll see how this works. So you can see me doing the work a little bit clearer. So the first thing it asks, it says, what is the area of the yard? Well, what do we know? We know that it has a length of 22 yards. Okay. We also know that it has a width of 9. That's the whole yard. Okay. We want to know what the area is for part A. So part A is asking us the area. Okay. So we know the area. Oh, I don't know why I did a second one line there. Area equals, sorry guys, first time. We know that area equals length times width. Okay, now you could have used any method that you wanted to in order to solve it. You could have chose lattice method. You could have chose area method. I'm just going to show you with the standard method. Okay, you could have done distributive method or property, I'm sorry. Okay, so 22 times 9. And we know that this is 22 yards times 9 yards. Okay, so we know 9 times 2 is 18. Put my 8 down, carry my 1. Okay, 9 times 2 again is 18 plus 1 is 19. So now what we know is we know that we have a backyard that is in a rectangular shape. Trying my best, pretend that's perfect. We know that one side is 9 yards. Okay, and we know that the width is 22 yards. Whoops, I mixed that up. I'm sorry. We know that the length is 22 yards and the width is 9 yards. Okay, and now we know that the area of the entire inside is 198 yards squared. Because yards times yards makes yards squared. Okay, now we're going to go to B. No, I don't think I'm going to be able to fit all of this on here, but I'm going to do the best I can. Okay, B. It says he decided to put in a rectangular pool. The pool is going to be 3 by 7. What is the area not including the pool? So what is it that we know? We know that we have this rectangular backyard. Okay, and now we know that he's putting in a pool. So when they ask us for that space, we want this area space that does not include that area with the pool, right? So we have 198 yards squared. And we know that we are going to have to subtract whatever the pool is. That's my plan. I'm sorry, I know I'm not doing a problem-solving box on here. I'm just explaining it as I go because it's too hard for me to draw that all out. Okay, so now we need to find what that pool area is because that's what the variable that we don't know. Now what we do know from looking over here is that the pool area was 3 by 7. That means that it was 3 feet by 7 feet. Okay, or yards, I'm sorry, not feet. 3 times 7 gives us 21. We should know that from our fast facts. So we have 21 yards squared. All right, so now that we have the area of the pool, okay? We can subtract that from our 198. So I'm just going to erase where we wrote pool, okay, just to save space. And I'm going to write minus 21. And we know it's yards squared, okay? So 8 minus 1 is 7. 9 minus 2 is 7. And 1 minus nothing is 1. So we know that without the pool, it is 177 yards squared. All right. So let's move on to C. It says, Jonah wanted to make sure that no children could get to his pool without an adult to keep everyone safe. To do this, he has to put up 2 fences, one around the perimeter of the pool and one around the entire backyard. So now what do we know? We know that he has to put a fence around. We know that we're working with perimeter because it's going around. Perimeter means that you're, for a rectangle, sorry, I should have put a line there. It means that you are adding all the sides together. And in terms of a rectangle, remember that means 2 times the length plus 2 times the width, right? So we need to find out what the perimeter is of the pool. And we also need to find what the perimeter is of the whole backyard. And I'm just going to write BY for backyard. Okay. Now we need to go back up to the initial information that they gave us in this top. Okay, and we need to say that it is 22 by 9. Okay, and we know that the pool was 7 by 3. Okay, so when we solve this, we're going to say 22 plus 22 plus 9 plus 9, or 22 times 2 is 44. Okay, now I'm going to take this 9, and in my head, I'm going to say, okay, I know that 9 times 2 is 18. So when I'm going to add 18 to 24. 8 plus 4 is 12. 4 plus 1, sorry guys, that is a plus 1. 4 plus our extra 1 is 5, plus another 1 is 6. Okay, so we have 2 lengths and 2 widths, so we know that the perimeter of this one over here is 62. And now we need to find the perimeter of the pool. So we're going to have 7 times 2 is 14. And 3 times 2 is 6. And when we add that together, we're going to get 4 plus 6 is 10. No, I'm not going to be able to fit it there. 4 plus 6 is 10. We're going to move this line up. Sorry, guys. Super messy. All right. 10. And then 1 plus 1 is 2. So the perimeter of our pool ends up being 20 and 62. Now they're building both fences. So that means that we need to find out how much it is together. So we need to add 62 plus 20 . 2 plus 0 is 2. 6 plus 2 is 8. So that tells us that they're going to need 82 yards of fencing in order to create both of those fences. Now let's go back to our question. It says that it costs $9 per yard. How much did it cost him? Well, if 1 yard is $9, we have 82. We know that we need to multiply. So we're going to take 82 and we're going to multiply that by 9. Now, if you didn't know your 9 facts, you should have listed out your multiples of 9, 9, 18, 27, and gone on 36, 45, 54, 63, all the way up until you got to 90, and then you should have crossed that out because we should never be multiplying by 10 or dividing by 10 when we're using our multiples, right? Okay, 9 times 2 is 18. 9 times 8 is 72, plus 1 is 73. Okay, and you guys should have double checked that with another method, but you would have got that C cost $738. Now, in case we need this information, I'm just gonna write the answers for A, B, and C quickly because it doesn't let me scroll. So if you need to go back and look at any of that information again, you can. Actually, I'm just gonna, so C was, just in case you didn't see it, okay, just in case you missed it, and you can't read it at the bottom because I know that's really small. C ended up being $738 in order for him to create the fence. Okay, so let's erase everything. Whoa. Okay. Sorry, it's just taking me a minute. I wish I could, oh wait, can I just do this? Clear all drawings. Oh, that's way easier. All right, guys, I'm just learning as we go too. All right, so now it gives us a new piece of information, okay? It says he then decided he wanted to add a garden area. So in your head, when you're picturing that backyard, okay, you have the full backyard, you have the pool, okay, and now we're adding in a garden area. And I'm just gonna write pool, and now I'm gonna write garden, a G for garden. Okay, so in your head, you should have pictured that somehow so that you're understanding, because remember, we're always visualizing when we're reading. Okay, so he decided to add a garden. He wanted to add roses, daisies, and tulips. Roses cost $15 per square, daisies cost $10 per square, and tulips cost $12 per square. Okay, it says the garden had a side length of 5 feet in an area of 15. So for D, we're looking at the garden. Okay, so we have our little garden area, and it says it has a, I'm just going back to the problem, okay? It has a side length of 5, and we now know that the area or the whole inside is 15. Now what they're asking us to do is find that side, and we did a lot of these. Remember, this is when you take that equation, and we know area equals length times width of a rectangle, right? Or a square. Okay, area equals length times width, and we're gonna fill it in. So we have 15 is equal to 5 times what? Okay, now here's where you could list out your multiples if you didn't know. 5, whoops, sorry, 10, 15. 5 times 1, 5 times 2, 5 times 3. Okay, so we now know that the width is 3 of our garden. Okay, now if you were super smart and you looked down and you were like, Miss Lauder, you gave us the picture, you're absolutely right, I did. Okay, the picture over here showed you 1, 2, 3, 4, 5 square yards by 1, 2, 3 square yards. Okay, now part E was, you could have done this many different ways. I'm just going to give you one quick example. I'm actually going to bump this over a little bit. Okay, I'm just going to give you one quick example, and you could have done it a million different ways that fit however you wanted to do. This is where you could have been creative. Okay, so I gave you this square. Whoops, that's a really bad square. Let's try that again. I didn't know I was going to erase all of it. Oh, Can I? Haha. Oh, here's our square. All right, and I am going to split it up by 3 this way. 1, 2, 3. And by 5 this way. 1, 2, 3, 4, 5. Okay, it's not perfect. It's the best I could do right now. Okay, now when you looked over here, it said he wanted to spend $250. So let's say that I decide in my head I want to do, roses are supposed to be red. Okay, so the roses, oh, I'm not, sorry. Roses are going to be $15. Okay, now let's see if I'm doing this. I kind of want this middle row right here to be roses. So I would have colored these in. Okay. Now this would be a trial and error. Okay. So then it says daisies are yellow. And I don't know if you can really see yellow that great. So I'm going to kind of make it a stale orange. Oh, that's awful color. Let me see. If you can't read it, then I will. You can kind of see it. Okay. Daisies. I'm just going to write D just for the sense of it. We'll make that a period. Daisies are $10. Okay, so let's say I want to then do daisies next. And you would have colored in those whole boxes. Miss Slattery is just scribbling it to make it go quick. Okay, and then tulips are going to be blue, and the tulips cost $12. I'm just going to write T. Tulips are $12. Okay, so I would have colored these in. Now here's where the math comes in. He does not want to spend more than $250. Okay, what's one way that he could design it? So now here's how I'm going to double check to see if my design works. And if it doesn't work, that's okay. I'm just going to try to change it up. Okay, so if roses are 15, the way I have this designed is I have 15 square. I have $15 times 3 of the squares. Okay, 1, 2, 3. And they each cost $15. 5 times 3 is 15. 5 times 1 is 3. I'm sorry, 3 times 1 is 3, plus 1 is 4. So the roses right now are costing me $45. Okay? So if I'm starting at $250, by adding that row of roses that cost me $45, let's see how much I'm going to have left. Can't subtract. So 10 minus 5 is 5. 4 minus 4 is 0. 2 minus nothing is 2. I still have $205 to go. So let's see how many daisies I have. 1, 2, 3, 4, 5, 6. I have 6 daisies. I know that $10 per square of 6 squares of daisies is going to be $60. Five minus 0 is 5. I cannot do 0 minus 6, so I need to borrow. 10 minus 6 is 4, and I bring my 1 down. I still have $145. Now this time I have 1, 2, 3, 4, 5, 6. I have 6. Again, so 12 times 6. Now again, that should be one of my fast facts, but if I don't know, I can use my standard form of multiplication or any of the other forms that we've learned. 6 times 2 is 12. 6 times 1 is 6. Plus 1 is 7. So now I have $145. I'm just moving over here, guys, so that you can see it. and I need to subtract that $72. Okay. 5 minus 2 is 3. 4 minus 7 can't do. 14 minus 7 is 7. Okay, my design works, and he actually has $73 left over. So that would be a reasonable design that he could have used. Okay, that doesn't mean that's the only way. There are many other ones. All right, I hope that this helped, and I hope you did a great job. I love seeing all of your work. Good luck with the next problem of the week. Okay, so how do I see? Oh, stop. I got